All right. So 8.2, 8.2, 8.2. So you might have learned this already, you might have not. So we're gonna be talking about frequency and period in this class. Right. So let's say you have a high frequency, right? And so high frequency means you have more wave cycles in a given amount of time. And I haven't covered period yet. You don't know what period means yet, but period is really the time it takes for one wave cycle to occur. So what is the relationship between frequency and period? And this image shows you it fairly well, right? So you have a high frequency, you have a lower period. If you have a lower frequency, you have a high period, a rather larger period. And so you have an inverse proportion, right? So they're inversely related. There's an inverse proportion here. So you see this on your reference table, page 5. And I'm actually going to go into the definition first. So again, your frequency measures how many wave cycles occur in a given amount of time. As you can see on the GIF, one wave cycle occurs in 4 seconds, so it's cycle over time. Actually, want to draw on this. And period is essentially, what is the amount of time it takes for one wave cycle to occur? So essentially, you can think of it this way. Well, cycle is the amount of number of wave cycles that occur and over time. So I would kind of remember this. And then your period, right? Period, capital T, that's period, is essentially the time it takes for one wave cycle to occur. So it's just time over number, right? So time over number. So as you can see, they are the inverse of each other. They're opposite. They're flipped because there's an inverse proportion here. So you can say that, well, the period, right? My period is equal to 1 over my frequency. And this is on your reference table. This is on your reference table. Right? It's important. You can always look back to this. Let's do this practice problem, right? So let's say if a kangaroo reaches the other side in 1 second, what's the frequency of the kangaroo? Again, frequency is the number of wave cycles, right? The number of wave cycles that occur in a period in a certain amount of time. Well, how many wave cycles occur? Well, wave cycle is either one up, one down, crest to crest, or trough to trough. Here it's just easier to do one up, one down. So one up, one down, one up, one down. So there's 1, 2, 3. There are 3 wave cycles that occur in 1 second. And thus, my frequency here is 3 hertz. The unit for frequency is hertz. What about period? Well, we can also follow the same logic here, right? We can use the formula, and that's the easiest way. Your period is 1 over frequency, which is essentially 1 over 3, which is essentially also just 1 over, well, I'm going to use a decimal, right? So 0.33 seconds. That's how you measure period. That's time. Alternatively, you could use the definition of period. The period is the amount of time it takes for one wave cycle to occur. So it's essentially time over number. So your time is 1, and the number of wave cycles 3, and so you still get the same number. It looks the same because I simplified it, right? I said 1 second. For other different numbers of time, right, or like 5 seconds, it's going to look a bit different. All right. So the answer is that. That's how you solve the answer there. I hope this is good enough, easy enough for you guys. So you have a period, that's a period of a sound wave, have a frequency of this, 340 hertz. So you're going to use your period formula. So 1 340. Sure. And we'll turn this into scientific notation. Right, so 1, 2, 3. 2.4 times 10 to the negative third seconds. Right? So that's my period. So question 2C. So you have a sitting bull fish reserves of 2 complete waves. So the number of wave cycles that occur is 2 wave cycles that occur in 4 seconds. The question is, what is the period of the waves? Well, you can do things 2 ways. You can be like, well, my period is the time it takes for a certain number of waves to occur, right? It's time over number. So you can just do 4 divided by 2 is 2 seconds. So your period for each wave is 2 seconds. That's simple. Right? There's not much more than that. Alright, let's go straight into it. Speed of a wave. You're given this formula on your reference table. Your velocity is equal to frequency times wavelength. Lambda, right? That's the symbol. That's how you call the symbol. So let's say you have high frequency. Well, clearly, if you have a high frequency, well, you have a small wavelength, and if you have a lower frequency, right, you have a bigger wavelength, right? So it's inverse. Wavelength and frequency are inversely related, or inversely proportional, right? Which means that, well, if your frequency goes up, well, then your wavelength goes down. If your frequency goes down, well, then your wavelength goes up. They're inversely proportional. This question right here says, what is the speed of the wave? If the frequency is 8 hertz, so what is your speed? Frequency 8 hertz. And clearly you're missing something, right? Because we know that the speed of the wave is frequency times wavelength. We know frequency, we want to solve V, but we don't know what my lambda is. We don't know what wavelength is. Well, let's look at the diagram. So your wavelength is along the x-axis. This is your amplitude. There's nothing, no impact on our question. That's amplitude. This is amplitude. Now a wavelength again is 1 up, 1 down. Right, so 1 up, 1 down. So that's a wavelength of this wave. That's 1 wave cycle. And since there are 3 wave cycles here, right, so there are 3 wave cycles here, and this is the entire length of all 3 wave cycles, well, do 6 divided by 3 and you get 2 meters. And that is the wavelength of this wave cycle. So lambda is going to be 2 meters. So 8 times 2, so 16 meters per second. All right, and so that's your answer. Alright, next question. A surfacing whale produces water wave crest having an amplitude of 1.2 meters. The amplitude, again, does not matter. It does it every 0.4 seconds. So 1 wave cycle occurs every 0.4 seconds. So that's actually your period. Because, again, your period is the time it takes over a number of wave cycles. So if it takes 0.4 seconds for 1 wave cycle to occur, well, that's 0.4 seconds, right? So your period is 0.4. A water wave travels at 4.5 meters per second. So that's your velocity. The wavelength of the wave is what? So you're missing frequency here, right? But we know we can solve for frequency because we know that period and frequency are inversely related. All right, so we have 0.4 is equal to 1 over frequency. Because we know they're inversely related, we can just cross multiply, right? So we actually just flip it. You can just actually flip it because literally they're inverse. So you can just flip f and 0.4, and so then you're gonna get 2.5 hertz, and that's gonna be your frequency. So you have V is equal to frequency lambda 4.5, 2.5 lambda 2.5, 2.5, and you get 1.8 meters, and that is your wavelength. 4C, if the amplitude of wave traveling on a rope is doubled, the speed of wave in the rope will do what? Now, it will be good to remember that, well, your velocity is equal to frequency times lambda. And, well, even though your amplitude is doubled in the formula for speed of wave, does amplitude matter? Is amplitude in your formula for speed of a wave? No, it's not. So even if you double your amplitude, nothing happens to your speed. So your speed will remain the same. It has nothing to do with the speed of the wave. Okay.